past few videos, we have looked at how we work with quadrilaterals. Now we're going to look at how we prove different quadrilaterals on the Cartesian plane. In this section, we're going to focus on the following shapes: trapezium, parallelogram, rhombus, rectangle, square, and kite. To better explain how we prove these shapes, let's look at some examples. If points A, B, C, and D are given, what type of quadrilateral is ABCD? Justify your answer. Let's start with a quick sketch. We can draw in our x and y axes. Point A has the coordinates -2, -10. So we can plot this down here. Point B has the coordinates 22, -10. So let's plot this point over here. Point C has coordinates 27, 2. So we can plot this point over here. And point D has coordinates 8, 14. So we can plot this point as well. Now we can join our points and draw our quadrilateral. Diagrams don't have to be to scale, but they should give us a general idea of what we're working with. From the diagram, we can see that points A and B have the same y coordinate. So this is a horizontal line. CD is not a horizontal line. So straight away, we can see that AB and CD are not parallel. Now a square, rectangle, parallelogram, and rhombus all have two pairs of parallel lines. So this cannot be any of those shapes. We can also see that this is not a kite. It's not the right shape. This means the only possible quadrilateral we have left is a trapezium. To prove a quadrilateral is a trapezium, we have to prove that one pair of opposite sides is parallel. We know that AB is not parallel to CD, but what about AD and BC? To prove that two lines are parallel, we need to show they have the same gradient, so we can use the gradient formula. Let's start with the gradients of AD. Let's say that A is our first point and D is our second. Now we can say the gradient M of AD is equal to 14 minus -10 over 8 minus -2. 14 plus 10 gives us 24 over 8 plus 2, which is 10. 24 and 10 are both divisible by 2. 24 divided by 2 gives us 12 over 10 divided by 2, which is 5. Now we can find the gradient of BC. Let's say that B is our first point and C is our second. So now we say the gradient of BC is equal to 2 minus -10 over 27 minus 22. 2 plus 10 gives us 12 over 27 minus 22, which is 5. Now we can see that AD and BC have the same gradient, which means that these sides are parallel. This is all we need to prove that the quadrilateral is a trapezium. So as our answer, we can say ABCD is a trapezium because one pair of opposite sides is parallel. Now we need to show which sides, so we can say AD is parallel to BC because the gradient of AD is equal to the gradient of BC. Let's do another example. Prove that A, FGHI with coordinates F -44, G -30, H 5 -5, and I 0, 3 is a kite. Then part B, prove that the diagonals FH and GI are perpendicular. Let's start with part A. Before we start, let's draw a quick sketch of what we're working with. Let's draw in our x and y axes. Point F has coordinates negative 4, 4. You can plot this over here to the left. Point G has coordinates negative 3, 0. So this point sits on the x-axis. Point H has the coordinates negative 5, 5. So you can plot this point down here. And point I has the coordinates 0, 3. So this point sits on the y-axis. Now we can join our points and plot our shape. There are numerous ways to prove that a quadrilateral is a kite, but it is always good to work with what you've been given. One of the most important characteristics of a kite is that two pairs of adjacent sides are equal in length. From the diagram, we can assume that FG is the same length as FI, and that HI is the same length as GH. So now we need to prove it. We need to find the lengths of each side. So let's use the distance formula. Let's start with FG. So we can say side FG is equal to, let's open a bracket, 0 minus 4, close the bracket, squared, plus negative 3 plus 4, close the bracket, squared, all under a square root. 0 minus 4 gives us negative 4. Let's put this into a bracket, squared, plus negative 3 plus 4 is 1. And we know that 1 squared is simply 1. Put this all under a root. Negative 4 squared gives us 16 plus 1 under a square root. 16 plus 1 is 17 under a square root. We are comparing lengths, so we can leave our answer in third form. Let's make some space and we can find the length of FI. So we can say FI is equal to 3 minus 4, let's put this into a bracket, squared, plus 0 plus 4 into a bracket, squared, all under a square root. 3 minus 4 is negative 1, and we know that negative 1 squared is positive 1. 0 plus 4 is positive 4, so 4 squared under a square root. Now we have 1 plus 4 squared is 16 under a square root, and we know that 1 plus 16 is 17 under a square root. FG and FI both have a length of square root 17 units. The lengths are the same, so we can make a note that FG is equal to FI. Let's also use small lines and mark the equal sides on the diagrams over here and over here. Now we can make some space and look at the other pair of adjacent sides. Let's start with GH. So we can say GH is equal to negative 5 minus 0 in a bracket squared plus 5 plus 3 in a bracket squared, all under a square root. Negative 5 minus 0 is negative 5. So let's put this into a bracket squared, plus 5 plus 3 is 8. You can say 8 squared under a square root. Negative 5 squared gives us 25, plus 8 squared is 64, all under a square root. 25 plus 64 gives us 89 under a square root. Again, we can leave this answer in third form. And finally, let's find the length of HI. So we can say HI is equal to negative 5 minus 3 in a bracket squared plus 5 minus 0, close the bracket, squared, all under a square root. Negative 5 minus 3 gives us negative 8. Let's put this into a bracket, squared, plus 5 minus 0 is 5, squared, all under a square root. Negative 8 squared gives us 64, plus 5 squared, which is 25, under a square root. 64 plus 25 gives us 89, under a square root. These two lines both have a length of square root 89 units, so we can make a note that GH is equal to HI, and we can mark the equal sides on our diagram over here and over here. Now we've proven that two pairs of adjacent sides are equal, which means that this quadrilateral is a kite. So we can make some space, and as our final answer, we can say FGHI is a kite because two pairs of adjacent sides are equal. Let's also include which sides we're referring to. So we can say FG is equal to FI and GH is equal to HI. Now we can move on to part B. Prove the diagonals FH and GI are perpendicular. This kite has two diagonals, one from F to H. Let's draw this in a blue dotted line, and another from G to I. You can draw in this diagonal as well. To prove the diagonals are perpendicular, we need to use the gradient formula and show that the product of the two gradients is equal to -1. Let's start with FH. Let's say that F is our first point and H is our second. So now we can say the gradient M of FH is equal to -5 minus 4 over +5 plus 4. -5 minus 4 gives us -9 over 5 plus 4 is +9. Now the 9's will cancel and we're left with -1. Now let's find the gradient of diagonal GI. Let's say that G is our first point and I is our second. And we can say the gradient of GI is equal to 3 minus 0 over 0 plus 3. 3 minus 0 gives us 3 over 0 plus 3, which is also 3. Now the 3's will cancel out and we're left with +1. Points J, K, L, and M are given. What type of quadrilateral is J, K, L, M? Justify your answer. Here we've been given a diagram. It may not be to scale, but it gives us a good idea of what we're working with. The diagram looks like it could be a parallelogram or a rectangle, but unlike a parallelogram, a rectangle has interior angles of 90 degrees. So let's try and prove this. If an interior angle is 90 degrees, then the two adjacent sides are perpendicular. So let's use the gradient formula to find the gradients of side JK and JM. Let's start with JK. Let's say that J is our first point and K is our second. So now we can say the gradient of JK is equal to 0 minus 8 over -10 plus 4. 0 minus 8 gives us -8 over -10 plus 4 is -6. Now the negatives will cancel. 8 and 6 are both divisible by 2. 8 divided by 2 is 4 over 6 divided by 2, which is 3. Now let's look at the adjacent side JM. Once again, let's say that J is our first point and M is our second. So we can say the gradient of Jm is equal to -4 minus 8 over 12 plus 4. -4 minus 8 gives us -12 over 12 plus 4, which is 16. 12 and 16 are both divisible by 4. -12 divided by 4 gives us -3 over 16 divided by 4, which is 4. 4 over 3 multiplied by -3 over 4. Now the 4's will cancel, the 3's will cancel, and we're left with -1. But in order to confirm that this is a rectangle, we need to prove that it's not a square. All 4 sides of a square are equal, but in a rectangle, only opposite sides are equal. Adjacent sides are not equal. So let's make a note that JK is perpendicular to JM. And now we need to find the lengths of 2 adjacent sides. Let's make some space. And now we can use the distance formula to find the lengths of JK and JM. Let's start with JK. So we can say JK is equal to 0 minus 8 in a bracket squared plus, open our second bracket, -10 plus 4, close the bracket, squared, all under a square root. 0 minus 8 is -8. Let's put this into a bracket, squared, plus -10 plus 4 is -6. Let's put this into a bracket, squared, all under a square root. -8 squared gives us 64, plus -6 squared is 36, all under a square root. 64 plus 36 gives us 100 under a square root. We know that the square root of 100 is 10, but because we are comparing the length of 2 sides, let's leave our answer in third form. Let's make a note of the length of JK on our diagram, and now we can make some space and find the length of JM. So we can say JM is equal to -4 minus 8 in a bracket squared plus 12 plus 4 in a bracket squared, all under a square root. -4 minus 8 gives us -12. Let's put this into a bracket squared plus 12 plus 4 is 16. Say 16 in a bracket squared, all under a square root. -12 squared gives us 144, plus 16 squared is 256, all under a square root. 144 plus 256 gives us 400 under a square root. Again, we can leave this in third form. Let's write down the length of JM on the diagram, and now we can make some space. We now know that side JK is not equal to side JM, so this is not a square, but it has interior angles of 90 degrees, which means it must be a rectangle. So, as our final answer, we can say JKLM is a rectangle because there is a 90-degree interior angle where JK is perpendicular to JM. And adjacent sides are not equal because JK is not equal to JM. Now we can see that the gradient of JM is the negative reciprocal of JK, but we still need to prove that the product of these two values gives us -1. So we can say the gradient of JK multiplied by the gradient of JM. Let's do another example. PQRS is a quadrilateral with P with coordinates 1, 6, Q with coordinates -3, 3, R with coordinates 3, -5, and S with coordinates 7, -2. Part A, prove that PQRS is a parallelogram, and B, prove that the parallelogram PQRS is a rectangle. Let's start with part A. Prove that PQRS is a parallelogram. The easiest way to prove that quadrilateral is a parallelogram is to show that the diagonals bisect. And to do this on the Cartesian plane, we simply show they have the same midpoint. In the diagram, we have two diagonals, PR and QS. So let's use the midpoint formula to find the midpoint of each diagonal. Let's start with PR, and we can say the midpoint of PR is equal to, open our bracket, the x coordinates 1 plus 3 over 2, and for the y coordinates 6 minus 5 all over 2. Now we close our brackets. 1 plus 3 gives us 4, so we have 4 over 2. 6 minus 5 is 1, so we get 1 over 2, and close our bracket. 4 over 2 is actually 2. 1 over 2 is in its simplest form. We can leave the y coordinate as 1 over 2. Now let's find the midpoint of QS. So we can say the midpoint of QS is equal to, open a bracket, we have -3 plus 7 over 2 for the x coordinates, and for the y, 3 minus 2 over 2, and then we can close our bracket. -3 plus 7 gives us 4 over 2 for the x coordinate, and for the y coordinate, 3 minus 2 is 1 over 2, and we can close the bracket. 4 over 2 gives us 2, and the y coordinate is still 1 over 2. These are the coordinates of the midpoint of PR and the midpoint of QS, so the diagonals bisect. So now we can say PQRS is a parallelogram because the diagonals bisect. And to prove this, we simply say the midpoint of PR is equal to the midpoint of QS. Now we can move on to part B. Prove the parallelogram PQRS is a rectangle. To prove that a parallelogram is a rectangle, all we have to do is prove that one interior angle is 90 degrees. In other words, that two adjacent sides are perpendicular. So we can use the gradient formula and consider PQ and PS. Let's start with PQ. Let's make P our first point and Q our second. So we can now say the gradient of PQ is equal to 6 minus 3 over 1 minus -3. 6 minus 3 gives us 3 over 1 plus 3, which is 4. Next, let's find the gradient of side PS. Let's say that P is our first point and S is our second. So now we can now say the gradient of PS is equal to -2 minus 6 over 7 minus 1. -2 minus 6 gives us -8 over 7 minus 1 is 6. 8 and 6 are both divisible by 2. -8 divided by 2 gives us -4 over 6 divided by 2, which is 3. These gradients are negative reciprocal fractions, but we still need to show that their product is -1. So we can say the gradient of PQ multiplied by the gradient of PS is equal to 3 over 4 multiplied by -4 over 3. Now the 3's will cancel, the 4's will cancel, and we're left with -1. Now we can write down our final answer. We already know that PQRS is a parallelogram. So we can say the parallelogram PQRS is a rectangle because adjacent sides are perpendicular. Now let's specify which sides we're referring to. And we can say PQ is perpendicular to PS. Let's do one final example. Points T, -6, 4, U, -7, -3, V, 8, -2, and W, 3, 7 are given. A, determine the midpoint of TV and UW. And B, is TUVW a parallelogram? Justify your answer. Let's start with part A. Determine the midpoint of TV. Let's use the midpoint theorem. And we can make T our first point and V our second. So now we say the midpoint of TV is equal to, open our bracket, -6 plus 8 over 2. And for the y coordinate, 4 minus 2 all over 2. Close our bracket. -6 plus 8 is 2 over 2. For the y coordinate, 4 minus 2 is also 2 over 2. 2 over 2 gives us 1. So our midpoint is 1, 1. Let's make a note of this up here. And now we can move on to part 2. Determine the midpoint of UW. Let's say that U is our first point and W is our second. Now we can say the midpoint of UW, so open a bracket, we have -7 plus 3 all over 2 for the x coordinate. For the y coordinate, -3 plus 7 all over 2. -7 plus 3 gives us -4 over 2. And for the y coordinate, -3 plus 7 gives us +4 over 2. And now we can close our brackets. -4 over 2 gives us -2. And 4 over 2 is +2. Let's also make a note of this up here. And now we can move on to part B. Is TUVW a parallelogram? Justify your answer. We know that TV and UW are the diagonals of the quadrilateral TUVW. If this was a parallelogram, the diagonals would bisect, which means they would have the same midpoint. We have just proven that the midpoint of each diagonal is not the same. So this is not a parallelogram. So to answer this question, we simply say TUVW is not a parallelogram because the midpoint of TV is not equal to the midpoint of UW. And we have now completed this question.